Thanks, Ed. Good afternoon, everyone. Thank you very much for joining us today. As Ed mentioned, my name is John Pickering. I'm operations here at Rapid International, and we're joined with Jarlath Gilmore here as well. He's our sales and marketing director. So, yeah, we'll just make a commencement on the presentation. So, as has been highlighted, we are going to be focusing on roller compacted concrete, its uses, its benefits, and the growing market that is a much easier accessible concrete paving in the world, and a growing market around the world globally today. So we're going to briefly run through a brief background on ourselves. Obviously, it wouldn't be us if we weren't unashamedly going to try and highlight some of our products and what they can do within this sector. Also, must say as well, we are machinery manufacturers. We are not concrete technologists. I'm quite sure that there's plenty in this call today that know an awful lot more about concrete and mixed designs than what we do. But we're just going to highlight a little today of what we've seen through our experience of the market and the way the world's going towards RCC. So we'll give a brief introduction to us as Rapid International, the HBM family, or hydraulically bound materials, of which RCC is a part. Then we're going to go into a bit more detail of what is RCC, the history of RCC, how it's produced, the materials and the mixing and all the transportation and all of that that's involved. We're also going to show some of the advantages of it, how it's recommended you mix it, and obviously we're going to recommend our equipment for that, where it can be applied, how the market's growing, and where you can learn more about this, different sources, references, and different associations around the world that focus on this. And then we're going to just show some project examples and a little video as well, showing just where this has been applied through our machinery around the world. So let's crack on with a bit of an introduction to us as Rapid International. The company was established in 1969 by Jim Lappin and my father, Bertie Pickering, as well. So we've been going over 52 years now, and started from humble beginnings, making agricultural equipment, and obviously that changed in the 70s, where we started to get into concrete mixing plant. And our first ever mixer, obviously in 1983, there, as you can see. We began exporting in 84, and our name then changed from Craigavon Engineering, as it was originally known, to Rapid International, as it is today. We went through a major rebrand in 2013. We have a strong international dealer network with over 1,000 installations around the globe in over 30 countries. We do have a large product portfolio that can do all sorts of applications, not just RCC. We can do your conventional ready mix concrete, precast, pre-stress, all of those things, even concrete reclaiming and things like that. We have a large portfolio for right across the concrete spectrum, and also we have a lot of spare parts inventory here on site as well. So a bit of the timeline: 1969, as I mentioned, we were originally known as Craigavon Engineering. Then 1983 we changed to Rapid International, and then in 2013 we adopted the brand that we are using today. You can see the humble beginnings that it all began in. This little small shed was where the first link boxes and pig trailers and things like that were produced. And then we started to expand and grow. And there's a photograph of one of our earlier truck mixers, a market that we've just dipped our toe back into again. So it's exciting to be back into that. And now we are operating out of our roughly 50,000 square feet under roof, and we have approximately another 15 to 20,000 currently being constructed here at the minute. So we're expanding our factory at the moment as well. So it has gone from strength to strength, and we have grown over the years. So a bit of the key facts: 65,000 square feet. As I mentioned, the last 15,000 square foot of that is just still being built at the moment. Over 50 years of leading industry mixing technology. We have been around this stuff long enough to be dangerous, as the saying goes. So, and as I said, we have exported over 30 countries worldwide. So we know a fair bit about how this market has grown and changed over the years, and it's exciting to see the growth of concrete being used for paving, especially here in the UK, that we're seeing that growth go. We are 100% green energy powered here. We have our own wind turbine on site and over 1,200 installations worldwide. I'm just going to pass over to Jarlath now. He's going to chat to you about the HBM family.
Good afternoon, everyone. As John took the link there, as machinery manufacturers, we are in many different sectors, and one of them is the roller compacted concrete sector. And today we're taking the opportunity to try and link the two together. And because it is a market area that's growing, it's growing significantly around the world, and it's something that we believe that anyone in this wider concrete spectrum should be taking a look at. By way of introduction to the sector, just give an overview of, we're coining here the HBM family. HBM standing for hydraulically bound materials. To those that will know it, is any soil or aggregate mixture that incorporates binders such as cement, lime, gypsum, fly ash, and that will harden with any chemical or hydraulic reaction with water. The main areas that have been common up until now is CBM or CBGM, two common phrases that's used in that, cement-bound materials or cement-bound granular mixtures. These were primarily used as sub-base layers and seen as a cost and effective way for heavy-duty and durable pavements. It's a fast way of laying it, and often trying to use surplus or lower quality materials, even larger pieces of rock or recycled concrete. This has been acceptable going over the last number of years, and people found it an easier way to get rid of burden material. But growing out of that has been the roller compacted concrete. Comes underneath the same family, generally coined as a higher strength option to CBM and CBGM, and is now being used more for mid layers and for finish layers in many applications around the world. So what exactly is it? It's a zero or negative slump concrete. It's actually compacted when it's being put down rather than consolidated using simple vibratory rollers. There's no formwork, there's no reinforcing steel, although some of this is changing with some of the developments in the sector. There's no finishing, it's just a rolled finish, and similar to doing with asphalt. Again, some of this is changing with the use of other materials for strength particularly. It's placed normally with high density pavers or double tamper pavers. For those that are familiar in the market, the likes of Voglay, Volvo, some of these brands have very high specification double tamper pavers, which will give you in excess of 90% compaction. There's no internal vibration. It's just the same consistency of damp gravel. The surface texture of RCC is quite smooth, and I'll show you a little slide just following this. So it's often ideally suitable for parking, any material handlings, big industrial areas, road pavings, anywhere where there's relatively low traffic speeds, maybe less than 60 miles per hour. Again, some of this is changing. In the US, they have done it in one highway. It was originally called the Aitken Highway. It can be designed to achieve compressive and flexural strengths comparable to even PQ, and maybe regarded as a pavement design purposes similar to unreinforced concrete. Just a little picture here to illustrate what I just said. So what you have is RCC in the middle. You can see that the texture of it is more similar to the asphalt on the right, and then you have on the more standard PQ on the left. So brief history. It started out in Canada in the 1970s. It was seemed to be a low-cost option for logging yards, and it was something that they drove through the necessity. That was then developed by the US Army Corps in the 1980s for the use of dam constructions, and that's carried on quite a bit since then. We ourselves supplied into a number of hydro dams into Mexico a number of years ago, where the government had a big drive to implement hydro dams for the use of electricity, and the RCC is deemed to be the choice there and continues to be so. Then through the likes of Australasia in the 90s, and then forced into Europe and Spain, and then in the UK here since 2002 and onwards. The likes of even Olympic Park, and we'll go through some other examples, have used extensive RCC for big industrial holding areas. So what does it all consist of? Well, it's your general cements and binders. I list here some of the AN standards. And I said at the bottom, you can refer to BritPave. We'll talk about that a little bit later on as some of the sources to look at the standards that are currently required. So general portland cements or blended cements are often used. Sometimes it can be a core of a CM1, maybe with a fly ash or silica being added as an additional auxiliary feed. Hydraulically road binders are the factory blended cements. As I said, extra silos and binders can be used throughout the mixing plant, and we'll touch on the mixing plant as we go forward. In terms of aggregate, it's conventional. Any aggregate that's used in conventional concrete can also be used. The better the quality aggregate that's being used, the better the finish and easier the mix. We often look at maybe sort of 14mm down as an ideal for roller compacted concrete, but we have seen people use a bigger spectrum in this. Again, as John said at the very outset, we're not concrete technologists, so often the mix designs are going to be personal or developed by the own companies who go forward into this sector. Unwashed or crushed concrete fines up to 10% passing through a 63 micron sieve can enhance the packing of the matrix. The key to roller compacted concrete is the compaction. And as I said, if you're using double tamper pavers and get 90% compaction on the first pass, then you're going a long way to make it a very good finish, whether it be a yard, a road, or similar. The aggregate strength, like anything, is extremely key. The one thing that RCC will often have to look at is the risk of cracks, and this is very important in regards to the better aggregate you're using, the easier that's going to become. Elongated particles and shapes is not recommended. Just like anything, it gets difficult when you're laying it and compacting it in a certain way. So the grading of the material, the densities and everything like that has to be very key to it. As I say, this is going to be something that each particular contractor is going to have to look at when they're own sourcing and grading their own material. Water within RCC is often the enemy. You know, as we said at the very start, it's a zero or negative slump concrete. So free water, often determining what's in your stockpile, is normally all that's required. And taking regular moisture readings is extremely important and key to the production of RCC. Add mixtures can be used just like any conventional concrete, be it reducers, retarders, or accelerators. Often we have to set up 1 or 2 add mixtures within the machines to allow that to be an addition. Again, that is mixed design equivalent or applicable. So, moving on to our key area, which is the mixing plants. It can be done in any type of mixing plant, but what we found that in RCC or CBMs, then what we need to be looking at is that the continuous mix plants often give the better performances, not only in terms of mix, but also in terms of throughput and the ability to get material to the pavers in the contract faster. Have to take into account exactly what you're doing in terms of whether or not you're using more than one aggregate. The likes of our machines allow this to be accommodated, and we can also provide guidance and information on in-feed systems for more blended materials. The ability to discharge into tippers or dump trucks, and we'll touch on the transportation a little bit later on. The last point, as I say, is the fact that, you know, the supply rate from mixing plants have to demand the paving rate. Some of these companies now are using up to 12-meter pavers, and the plants obviously have to produce 400, 500, 600, 700 tons an hour to keep up with it. The mixers that are often looked at as providing the best performance are twin shaft high energy mixers. Our particular unit turns at 110 RPM, 72 paddles inside a 14 feet long mixing chamber, which we believe is the fastest and best in the market. And I think some of the projects that our machines have been used has proven this. The accuracy of the plant and the machines is also very key. And from our point of view, we started out providing volumetric proportion units, and about 7 or 8 years ago, we developed this into a fully weighing plant that was giving you recordings and all your materials from your aggregate to your cement and your water, and that's providing the opportunity to go in and take on greater projects. It's also probably driven some of the RCC growth because of the contractors' demands to have the recordability of all the materials and all the finished product. And machines like ours has been able to provide that, from batch tickets to what they can download from the computer system. This is an illustration, a source from RCC Council in the US. It's a little bit dated, but it just shows the high level of use of Pug Mills, which is the high volume continuous mix plants like that we manufacture, being used compared to other mixture types. So that term Pug Mill is something that's sort of universally known. That figure doesn't necessarily mean, and I would like it to be, it doesn't necessarily mean it's just our plants, it's our plants and all the competitors, but you can see how Pug Mills completely dominate the market in regards to use within RCC. Touched a little bit earlier in the transportation. So generally it's always transported in dump trucks or tipper trucks. Likes of our plants do have a simple outloading conveyor with a separation gob hopper to allow dump trucks or tipper trucks to be lined up, collect the material and transport it down to the paving area, and being able then to transport it into the pavers themselves. It should never be, or certainly not recommended, that ever be transported in standard agitator or mixing trucks. In the likes of wet conditions, I mentioned earlier about the water being the evil within the sector. In areas that maybe there is a little bit of rain coming in, often the transportation needs to be done with the material being covered. Again, circling back onto the paver plant itself, we touched on the fact that double tamper pavers from a lot of the leading manufacturers like Volvo, Vogele, Dynapack have all got options like this available. Can be done with a standard asphalt paver, but again, it refers to what compaction rates you're going to get on first pass. Generally, some of the better double tamper pavers will give in excess of 90% plus, which leaves then the finishing of it a lot easier. The compaction itself has a direct bearing on the finish and the regularity of the surface, particularly on roads, which is obviously extremely important. Twin drum vibrated rollers is recommended, but PTR or pneumatic tire rollers can be effective, providing a smooth and tight surface. Smaller rollers may be employed around the edging and leaving for certain removal of certain roller marks. Wet form cracking can be introduced, obviously expansion joints, etc. at each point. It should be taking place as soon as possible. We'll touch on to the fact that roller compacted concrete, one of the advantages is that you can be driving on it in less than a few hours. So from compaction point of view, to curing point of view and everything else, a lot of that stuff has to be carried through in a timely manner. In terms of then moving on to the curing, as I say, it's a low moisture content, so it's susceptible to drying the surface, and particularly along the edges, it's very important to get your curing agent down as soon as possible to avoid particularly the cracking. Sufficient moisture must be retained within it, so there is an element there, but it's drying out is the one area that is very key to ensuring that the excellent finish for RCC. Some people may use, as per the picture, some type of curing membrane sprayed onto the surface. That also can be for other types of mixes, although the likes of CBMs, they often use like a bituminous emulsion membrane for that. So why RCC and CBMs? We're trying to put this all into this presentation because they are so linked. It's a growing area for road construction. It requires a lot less energy than asphalt. It saves on natural resources such as oil. In fact, in terms of the likes of the bitumen, it used to be a byproduct of production. It's now has to be made specifically. They're more resistant to extreme weather. It will also lead to lesser interventions over the lifespan of the road, hence the contraflows, and all the other hassles you have when you have roadworks at various times of the year. The 20% cheaper figure that I put up there, it is deemed that as a cheaper way of laying material. There's a lot of variables in that, so it is a guide. That will all depend on not only country to country, but material to material and the sourcing of that. But generally, there is some studies out there that has shown that it can be up to 20% cheaper in comparison to standard asphalt. A lot of that is maybe driven also by cement being cheaper than oil. Again, that is variable from time to time in regards to particularly the oil price being a little bit more volatile, although at this moment in time it's scarcely a cement. That may not be just always the case. I imagine the lifetime of the road can generally be extended. You know, we're expecting to put some of these roads down in the last 50 to 60 years with only maybe 3 or 4 major interventions. If you had to see an asphalt road in the same area, you'd expect maybe half the lifespan with maybe double or triple the interventions for maintenance and major repair. It's much faster laying down than conventional concrete even. In terms of maybe other aspects in terms of noise and everything else, it's also reduced in comparison to more conventional concrete roads. I touched on it earlier there that the ability to back onto the road in a very short space of time, we're saying up to 8 hours. We have examples of maybe some smaller residential roads and areas that they've driven on it within 4 to 5 hours. So traffic then is moving once again, which is important. Leading on to some of the other advantages, let's say the high strength of RCC in terms of some of the cement contents, it can be 10, 12, 14% of your mix design. It eliminates some of the costlier problems, certainly with more traditional asphalt. It's an economical pavement option. It resists deforming under heavy concentrated loads, especially in big areas like industrial yards where heavy equipment's on it all the time. It won't soften under high temperatures like you do have with asphalt. It doesn't deteriorate the same with fuel or hydraulics fuel spillages. And it will eliminate many of the traditional problems you have with hot mix asphalt, including rutting, any pavement punctures, surface spalling, and it significantly reduces the maintenance costs over the lifespan of the road. So ultimately, as we say here, economy is the mother of invention of roller compacted concrete. It was the reason the guys in the logging yards in Canada in the 1970s wanted to find an alternative. And I think it's in the world that we are living in today, it's becoming even more important. With the cost of materials, with the environment, the green factor, the speed of laying it down, and the lifespan of roads is all important. As we go forward, it may even be that other recycled materials can be used in it, and encapsulating these materials within a road for 50 or 60 years is better than going to landfills or any other way of disposal. So for yourselves, there's a number of different references, associations, and sources. I list a couple of the main ones here. So BritPave is one of the major sources that we would tap into. The little screenshot here shows there's a number of free downloads. There's some great people in there. John Donegan and his team and everybody else will be available and I'm sure happy to help. But even their online guides are extremely useful. Their sister UPave for those across wider Europe. In the US, the Roller Compacted Pavement Council, which we are members of as part of the bigger American Concrete Pavement Association, are also a great help. Some of the slides that I've referenced here today has been provided by them, and Corey Zollinger is one of the major contributors to that. He's provided some of the information for us here today, and I know that if you get in touch to him and his team through the website, they'll also be very much helpful to you because they're large pioneers of driving RCC across the globe. So I'm going to hand back to John to give a little bit more just on our plants as well and how they tie into the manufacture and growth of roller compacted concrete.
Thanks, Jarlath. As I said at the beginning, we are unashamedly going to highlight our products and what they can do. So a little bit of a background. In 1996, we saw the first model of our continuous mix range, the Rapid Mix 400. In the early stages, you can see the photograph, big blue there, was 70 feet long and weighed nearly 50 tons. With a good old historic video of it coming out of the gates here at the factory, and it looks like it's never going to stop coming through the gates. It's a bit of a beast. Material control was done entirely volumetrically back then. There was no weighing of any material. This method was accepted in the United States and Australia, but it wasn't an accepted method here in the UK, and it wasn't until we introduced our weighing, as Jarlath said, back in about, I think it was 2012, we introduced the weighing into that plant. So we've been manufacturing the rapid mix range for roughly 25 years now. So I think it's fair to say that we've refined this machine over the years, and we have it now that it is a very capable and all-round excellent plant for this concrete production. We have approximately over 100 of these units currently working around the world right now. As Jarlath mentioned, we believe it to be the fastest and largest pug mill mixing chamber in the world, of all of our competitors, which we highlighted as a very important part of RCC production. In addition to the rapid mix range, we can design and build bespoke plants and semi-static and modular continuous mixing plants. We have provided solutions to the likes of Liberia and Africa, where it was not a mobile plant at all. It was a static version of a continuous mix plant. It was actually 3 plants done in tandem with each other. So we can do bespoke design of these if your project requires. So a bit of an overview of what the plant looks like today. You can see a bit of a difference there in the two products, and how it has grown and changed over the years. But by and large, it's still the same. You've got your silo that stands up. It's a fully self-contained continuous mixing plant. The silo and the conveyor and the gob hopper are part of the self-erecting system. It's raised hydraulically. The current options are volumetric and full weighing, as we've said. We offer ranges now. We have also introduced, I'll show you later on, a 250 version. So we have a track mounted 250 tons per hour, 400 tons per hour, and 600 tons per hour. High speed mixing chamber at 110 RPM, fully adjustable material feed rates, your aggregate, cement, and your water, and integral operating control system with flexible control systems that are sourced locally here by PIL. I'm sure many of you know them. So we've been using PIL on these machines for the last number of years, and I'm sure a lot of you understand this level of support that they can offer. We believe it to be the longest and fastest chamber in the world, the onboard silo of 40 tons, and you have the option to add an auxiliary silo for additional feed or even just additional storage. It has its own onboard compressor and a unique, easy clean out mixing chamber where you can drop down the 2 sides of the mixer, get full access to the sides of it. We also have opening lids on top of the rapid mix, and a drag out conveyor underneath. So you can knock all the excess material off the paddles and shafts onto the conveyor and just run those out your outloading conveyor at the end of your day. So it makes cleaning of the mixer incredibly easy. Separation gob hopper with a timer set for easing of loading and segregation control. That allows basically enough material to be held at the top of your outloading conveyor to allow one truck to leave and another one to come in underneath, allowing totally uninterrupted continuous production of your material. As I mentioned, our little baby brother, the Trackmax 250, it's heavy duty construction mounted on tracks. We believe this allows more access to harder to reach sites and more difficult locations around the world. With a photograph later on, we have actually put one of these down under a mine in the Democratic Republic of Congo. So the low profile of this plant allowed it to get right down underground in the mine. You have 12-meter aggregate hopper with a division plate, so you can do 2 aggregates, or if you have more than 2, you can put a set of blending bins off to the side, remove that division plate, and it becomes a feed hopper. You can load from either side with low friction lining on the hoppers to allow any sticky materials to go through. This plant, as I'll highlight later, is used for a lot more than just RCC. We're doing a lot of soil stabilization, contaminated land treatments and things like that. So we are getting sticky clays and muds and stuff like that we've been asked to mix in this plant, and it's handling it very well. Variable speed feeder gates are variable feeder gates to allow for control of each material, and your belt feeder can also be variable speed as well, so that allows total controllability. aggregate weigh belt actually is on a pivot point, so that continuously weighs your aggregate as it's coming out of the hopper. Same mixing chamber as is in the rapid mix. We haven't changed that at all. If it's not broke, don't fix it. So it's the same system that we use in the rapid mix. So we know it's to be a highly effective and fantastic mixer for the job. And it has a double hopper cement weighing system. This is the same system as on the weighing rapid mix. So it's a continuous weighing system that allows for total controllability and readability and recordability of your cement. Again, the same clean out system. You don't have access to the top of the mixer on the Trackmax because that's obviously, as you can see, where your genset sits and providing your onboard power. But you do have access to your two sides completely, and your drag out conveyor is there as well. Your outloading conveyor for ease of discharge. We don't have the gob hopper on this one, simply because you can hold material for enough time on the belt to allow a truck in and out. And also, if you're going to be using this for anything other than RCC or CBM, it becomes a stockpile machine essentially. You can stockpile your treated material. 650 litre onboard water weighing system. Obviously, if you're going to be adding more water than that, you will need some sort of a bowser to go alongside the plant, but it does have a little buffer tank on board. Your genset, as I mentioned, is on board, so your power's all on the machine. You can add an admixture system, and you can even add a live screening grid to the top of your aggregate bin there to stop any bigger pieces of material getting in and jamming up the mixer. And again, the same automated software as what's on the rapid mix. So some of the applications other than RCC that I just mentioned, there's that photograph of the plant down inside a mine in Congo. So if we obviously have our RCC, we can do our bentonite enriched soils, soil cement or cement bound materials, as we've talked about, all our hydraulically bound mixes, as we've talked about. PQ concrete, so actual pavement quality wetter mix. We have done it out of these plants. There is a little bit of a design specification requirement where maybe you're adding your water a little later up at the top of the outloading conveyor just to allow the material to get up there. But there is a little bit of tweaking and a little bit of customer interaction that we would have to do and a few modifications to make to the plant, but it is capable of doing it, and we have done it on a number of occasions. Cement and lime soil stabilization. We're getting into an awful lot of these projects right now where you're just taking out a soil from the ground, treating it and putting it back down to allow for a road to be built or some sort of construction to happen on top of that. Sludge stabilization, tunneling and dredging. We've done a number of projects where there has been lake dredgings or riverbeds or things like that, where again, you're just taking a sticky, wet material, treating it with a lime or a cement and laying it back down somewhere else or bringing it to landfill. Cold bitumen mixes, we can do a bitumen out of this, obviously non-heated. So that would be using a foam mix or adding a cold emulsion. Grout and rock paste mine infill, that was one of the projects that they done in Congo, but they also paved their own road down into the mine as well. And in recent years, believe it or not, we have even been making concrete blocks out of these plants. So as you can see, a very vast range of applications. If you are in any of these industries, you can certainly find a use for our equipment in that. Just going to pass back to Jarlath, and he's going to talk a little bit more about how RCC is growing.
So just this slide is just to sort of tie all that in together and just look at some of the figures. Again, it's a little bit of an age slide that's been supplied to us on the left-hand side, but it shows a phenomenal growth of RCC in the last number of decades. And to be honest, if we were right up to date, I expect that to be continuing to grow in the same shape. So it highlights exactly where RCC is going. This is particularly for the US. I think since it was introduced in North America in the 70s, it's always been the lead way, and we're about to show you just some examples of where RCC has been extensively used. But as I say, we just wanted to highlight where it's going, and then on the right-hand side, you'll see some of the reasons again that we want to reinforce. It's been stimulated by competition, and what we mean by competition in regards to blacktop. It's been providing reduced maintenance costs, which is key to everything that we're looking at. It frees up budget for other roads, and currently in the current climate where every government's budgets and infrastructure budgets are having to be cut because of other areas, particularly health and what have you. It's key that budgets are spread better. The fast construction process is a big driver, being able to put the roads down quicker. And this also applies to yards, it applies to residential roads. As I said earlier about the Olympic Park in London, you know, when large events happen and they need big areas to hold, whether it be containers coming in or anything else, the speed of construction is key. Opening up traffic is a big driver to it as well, and a big key for anyone wanting to specify this. And the fact that people can be driving out within hours. The ease of placement here in the last one in the urban environment is, again, in them tighter spaces around residential roads and developments. The video we're about to show you is an early stage of a housing development in South Africa, and it's key to sort of being able to have the space and also work and get things moving without big areas being blocked off and closed off. So just as we wanted to say, from the early 2000s, the utilisation of RCC has expanded, but it's expanded also into smaller type of projects such as hike and bike trails, local and residential streets, roads, commercial car parks, industrial areas and everything else, as well as road construction, has allowed the wide spectrum to grow and grow and grow for the use of RCC, and we expect it to continue to grow. And for us as machinery manufacturers, that's obviously very exciting. We want to be able to continue to sell into this market and develop product into this market. And for a lot of those that are on the call today, whether you are involved in supplying materials into this sector, or like ourselves, involved in machinery, involved in mixed designs, working with companies and everything else, we hope that we collectively can continue this market to grow. Give you some just examples. These are all examples that our plants have been involved in over the years. So everything from JFK Airport to the hydro dams I mentioned earlier in Mexico, the Aitken Highway, which is one of the first highways ever to use RCC for some of the finished surfaces. Some of the local project here in terms of down in Enniscorthy, although that was primarily CBM, as was London Gateway, it just gives an example that we're doing it right across many markets, home and abroad. Jebel Ali Port Extension, the BMW factory in South Carolina, the Riga Airport, Teesside Port in the UK, and the Walmart distribution centre there that I touch on is happening right now. Walmart have had an expansion and 3 major projects. One of them, as I said, in the Carolinas, is the biggest project for Walmart in the US right now, covering 2.9 million square meters of roller compacted concrete at 254 mil, and a rapid mix plant is currently being used for that project. Just another example of a client of ours. This is just a screenshot of a LinkedIn post from a good customer called Rulecon in Texas. They've completed several RCC projects, mainly the Port of Houston, where they did 3 phases using a rapid mix the whole time. And the most recent one they've done is a road construction up in Liberty, Texas, in the northeast of Houston. And this LinkedIn post was as recent as the 23rd of June. And it gives you just an example of working in tandem. Again, you can see all the hashtags, not only hashtagging RCC, but also the RCC Pavement Council that we spoke about before. So we just want to give you a quick video presentation of just one project. It's in South Africa. What you're going to see is a little bit of the sub-base material, because we did the video in conjunction with our client at the time. But the key factor in this is not only is it a good representation of everything working in tandem, but it's also just the overview you'll see is it's the start of a large housing development project in South Africa.
So thank you very much for listening to us. Hope not too many of you fell asleep during that. We're happy to take any questions that you might have. I know Neil has been reading the chat there as you've been asking questions through there. So Neil, is there anything that you want to pass on from the chat?
Yeah, listen, thanks very much, guys. That was an excellent talk there, very informative there. We have quite a few questions coming through here, so we'll fire on a few to you there. And to anybody that didn't get their question answered, we will try and come back to you later on with an email response on that. So just a couple of very simple ones first that I'll answer, guys. Regarding certificates of attendance there, yes, we will be putting out certificates, CPD certs for this seminar. You'll probably get an email prompt, I would say, later on, that if you want one, just to come back to us, so as we're not doing lots and lots out for people who don't need them. So that will go out shortly after the event, hopefully. Let me see, we had another one there. Which was regarding the presentation. So it was, this presentation has been recorded. So again, if anybody is looking a copy of it, we should be able to send that out as well. We just need to sort that out with Michael at head office. So if we run through the technical ones here for John and Jarlath there, any ones that we can't answer today, we'll try and come back to you in an email here. So the first one, is there any experience or results using GGBS in RCC?
Not too sure, Neil. We haven't had any experience in using GGBS. Obviously, maybe want to find out exactly why the reason they're wanting to use that, but no, we haven't had any direct experience of customers that we know of used GGBS. I don't see any reason it wouldn't, because it's just a binder, but we have no direct experience of that being the option.
Okay. The next one here is from Nick. Is it possible to use a higher PSV aggregate in the mix to enable it to be used on higher speed roads?
I don't see any reason why not, as long as it's less than 75 mil is usually the stipulation to get through the plant. Not sure if that particular aggregate would be better for compaction or not, but certainly as long as it's 75 mil down, it'll be able to go through the plant okay.
I have another couple here from Sean then. Have you any experience with steel mesh or geogrid within the contract?
This is an area that is currently being looked at within the sector. I touched on it briefly. The likes of the large associations like the RCC Council in the US are looking at it extensively. And when I referred to it in the presentation, it had come from the US. We personally haven't had any project that our machine has been on that has used any sort of reinforcement, but I know that they are looking at that right now. Maybe even introducing fibers as well. So that's an ever-growing area, an ever-evolving area. And what I would say is keep an eye on the resources, the likes of BritPave and the likes of the RCC Council, and see what they're posting up and doing, because what they're doing is they're tying in what all the contractors are experimenting on, working on, and results that they're finding.
Okay, and another one here from Sean there. Is it possible to achieve an impermeable finish where you have a yard maybe with no runoff allowable, or all water has to be drained off into a tank or an interceptor?
That's probably one I'd have to research and come back. It's not something that we have our first-hand experience on.
Okay, no problem. What is the RCC single layer max thickness? And if more layers are required, do you place any interlayers if the lower is dried?
Again, I'll have to come back to you on that one.
Okay.
Because a lot of the pavers are evolving, and I'd have to look into that.
Yeah, some very technical questions here.
Yeah.
So everybody has said that sort of bear with us there, and we will try and get back and get everybody's question answered at a later point. Have you any experience there with people designing RCC mixes to answer to withstand freeze thaw cycles?
We haven't had it in any very climates. Like, I'm assuming this may be in Scandinavia or in Russia. We haven't had any experience in that personally ourselves, or any of the machines been on it. I know we have done it a little bit in Russia, but that was only wasn't sort of experiencing any extreme cycles. But we could investigate that with some clients and maybe come back to your client the question there.
Okay. And have you had any experience in using recycled concrete chips in RCC?
I do believe there has been, yes. Again, the unfortunate thing is that when we go to our clients, they have graded the aggregate, and I say as long as it can go through the plant, that our experience is then developing that mixed design to go into the plant. But I do believe there has been some recycled concrete chips used.
Okay. Another one here from Tony. When designing a road pavement and needing to carry out a layered analysis, can you let me know what material layer modulus you would use?
Again, I think that's the client specific on what they're doing. It probably us as a machinery builder wouldn't be involved in that. But again, we could try and direct that to one of the customers and let them provide the feedback, and maybe give the person they're asking the question some little bit more info.
Yeah. Okay. Thanks, guys. I suppose sort of the reverse of what we asked earlier there. Have you any experience with bound mixtures in permeable pavements?
Not a great deal, no.
No. Okay. And one here from Nick. How soon after laying do you generally open up to traffic? Well,
we said there that generally we're saying up maybe about 8 hours, but we have seen that in less, maybe within 4 to 5 hours. We even did a test one stage at one of the shows in Las Vegas where we did it with a couple of different teams. And what we were able to do was we were able to put down the layers, do the saw cut within a short space of time, and then have someone drive over it within 4 to 5 hours. I do know of other examples in fully fledged projects that have done the same. So normally maybe 6 to 8 hours, but you can do it within 4 to 5, depending again on just the finish and the particular road that you're doing it. The smaller, more residential road it is, the quicker you're going to be on it.
Okay, thanks guys there. We'll maybe just take a couple more. I see we're getting close to the hour mark there. We're talking about producing net zero carbon concrete. Are you able to do this with RCC?
Well, it certainly can contribute to it. We touched on it there that, you know, the type of materials, and particularly as we move towards using more recycled materials, it's going to contribute to having a lower carbon footprint than certainly using materials that are oil-based. So that's why it's one of the reasons why a lot of you know, governments as well as those setting the projects out are looking towards this. I know in other areas that John touched on in applications, we've been able to contribute heavily to reducing the carbon footprint, but RCC specifically will also do that, but that will also be evolving with the materials being used against the likes of the oil-based materials like asphalt.
Okay. I think there's one there that we had answered before there about maximum aggregate size and GTBS.
As long as it's 75 mil and less, yeah.
Yeah. And we'll just take that last one there. And have you had any experiences on airport pavements?
Yes, particularly for the aprons. We touched on it there with some of the projects like at JFK Airport. I mentioned Russia. It was done in Russia as well. In oh god, now I can't remember the airport. Riga in Latvia also was using our plants for airport pavement. So simple answer is yes, it has, particularly for aprons. It's RCC aprons. Okay,
well, listen, thanks very much. Well, there is more questions that are coming in there, but we're just not going to get through them all. So we'll take a note of these and we'll try and get back and answer, hopefully, as many as we can. Obviously, some are very detailed and very technical, so they are, and we'll take a wee bit of thought on stuff on there. All right. I'd just like to say a few thanks before we all quit here. On behalf of the Concrete Society Northern Ireland region, we'd like to thank Michael and his colleagues at the Concrete Society head office there for helping us set up this event and looking after the Zoom call and getting that all up and running for us. It was greatly appreciated. We'd like to thank our partners in this, the Irish Concrete Society, and in particular Rosie, for again keeping us on the right path, and all her experience with the umpteen Zoom presentations that she has already hosted there was very invaluable, and she certainly kept us on the right track there. And of course, John and Jarlath there from Rapid Engineering. A great talk there, and I'm sure everybody would got a lot out of it. I'm sure I certainly will anyway. So once again, I say just thanks to everybody who was involved in it. That was great.
Thank you.
Yeah, thank you very much, everyone.
Okay, so that's the end of our presentation there, and as I say, we have everything recorded there, so we will try and get back to as many people as we can regarding questions and the copy of the presentation and everything. So thank you very much.